The purpose of this section of the course is to teach you more advanced materials about functions. Now, the real power of functions comes from integrating control statements with functions, and that's why I've split up the videos on scripts and functions into two sections. And in this video, I want to show you how Matlab separates variables in separate workspaces, which are often called stacks. I like to call them Miniverses, but they're called stacks or workspaces. Now, in this and the following few videos, I'm going to be using a function called basic stats. You might remember this is a function that we created in a video called Creating Functions. It was several sections ago in the course. If you don't have the function basic stats because you didn't watch that video, then please go through that video before continuing on to this one. Now, before switching to Matlab, I want to explain conceptually how Matlab deals with multiple workspaces when running through and evaluating functions. So think of Matlab's memory buffer as being like a little self-contained universe. All of the variables that you create and work with inside this little universe, or miniverse as I like to call it, this is called the base miniverse. It's the default Matlab miniverse when you start Matlab. Now, when you call a function, Matlab is going to create a new miniverse just for that function. That little miniverse is totally independent of the base universe, meaning that the variables are not shared between the two miniverses, just like you cannot send emails to your doppelganger in a parallel universe. Well, okay, in this case, Matlab is actually a little bit more like a cheesy sci-fi movie. It actually is possible to get information into and out of these miniverses. There are several ways to transmit information across miniverses. You can use functions like eval_in or assign_in. There are persistent variables or global variables, but I'm actually not going to talk about those topics here. The main way to get information into and out of a function miniverse is through function inputs and function outputs. And then if the function you are working with, so you call a function, then Matlab creates a miniverse for that function. If that function calls even another function, then Matlab will create a whole new miniverse for that other function. Maybe we can call this a teeniverse. Now, the thing is that all of these miniverses are independent of each other, and information is sent across these miniverses primarily through function inputs and outputs. Now, here's the thing. When the function ends, the function finishes, that miniverse is destroyed. And so anything that existed in those miniverses is also destroyed. All of your variables and settings and parameters that you defined in these other miniverses get destroyed when that function ends. All right, so that's the conceptual idea. Matlab doesn't actually call these miniverses or teeniverses, unfortunately, in my opinion. The official term is stack or workspace. So now I'm going to switch to Matlab and demonstrate this concept to you. And I'm also going to show you how to get inside these other miniverses using a procedure called stepping in. So as I mentioned, we're going to be working with this basic stats function that we created in the section called scripts 1, or is the first scripts and functions section here. So what I'm going to do is step into this function so I can see its miniverse. But first, I want to create a few variables in the base workspace. So let's see, we'll do this one, ASDF equals this, and QWERTY equals this. It doesn't actually matter what these variables are called. We just want a couple of variables in the workspace. Okay, so I've created 3 variables in the workspace. Okay, and now in the basic stats function in this file, I'm going to add what's called a breakpoint. And a breakpoint is going to allow me to step into the function. You can add a breakpoint by clicking on this little horizontal bar next to a line of code. So it's only possible to add a breakpoint next to a valid line of code, not a comment or an empty line. Now you can see when I clicked on this horizontal bar, it turned into a red circle. It's like a little button, and this tells us that this is where the breakpoint happens. Okay, so now I'm going to run the function. This was called basic stats. And let's input, just a couple of numbers. Doesn't actually matter what we input. Okay, now check out what happened. The prompt down here changed a bit. MATLAB put a K in front of the prompt, in front of the cursor. And now if I type whos, this is going to be pretty interesting. We no longer see all of the variables that we have created. So here I typed whos. These were the 3 variables that I just created. And now I type whos again when I have this K for keyboard thing. So I'm stepped into this function here. And now when I type whos, the only thing I see is this variable invar, and that is the name of the input variable up here that we have defined. So we have traveled into this function's miniverse. We can no longer access the data in the base workspace. Now, of course, the base workspace is still there. We can go back to the base workspace by clicking on Editor, and here to the right you see function call stack. So this is currently set to basic stats, and now I click this and you can see another option is base. So now I select base and I type whos again, and now I see the original variables that I created, and we no longer see invar, and that's because we have transported ourselves back to the base workspace, and so we no longer have direct access to the information inside the basic stats workspace. Okay, so now I will go back to basic stats here. There are 3 ways to exit a function's workspace. So one way is you can click on Editor and quit debugging, this red stop sign here. You can click this one. You can also type on the keyboard, oops, that was supposed to be here in the command window, db quit. That will also allow you to quit. And a third option, a third way to break out of a workspace, let me step into this function again. So now I'm inside the function. You can also make a change to the function, and I'm actually just going to put a space here because I don't really want to change the code. I just want to change this script or this function file. And now I'm going to save. I'm pressing Control S on my keyboard, and that breaks me out of the stepping inside this little miniverse. If that's the first time you've done that, then when you save, MATLAB is going to open up a little dialog menu, and it's going to say, are you sure you want to save? This will get you out of the current stack. And then you can select yes. You can also optionally select don't warn me again, which is what I've done, and that's why I didn't get that warning message. Now this latter method, changing the file and then saving it to get out, that's not always possible, and it's not always a good idea, because, for example, this file might be a MATLAB function, or you might not have write privileges to this file. Okay, so I'm going to now remove this breakpoint by clicking on it again. And then just to show you that now without that breakpoint, the basic stats function runs through completely normally as expected. Okay, now I want to illustrate the concept that I call the Tiniverse, but it's basically just going down through multiple stacks. So what I'm going to do is create a sub function at the bottom of this function file. So at the bottom of basic stats, I'm going to add another function, and this is just going to be a replacement for the mean function. So I'm going to say function y equals, let's call this the mean with a capital M, the mean x. And then here we know what the mean, how to compute the mean. We just say y equals sum over x divided by the number of elements in x. So there you go. Okay, so now we've created this function, and you can see actually there's a little warning message under here. MATLAB is saying the function the mean might be unused. So what I want to do is replace the function called mean with my function the mean. Okay, now I'm going to save this file, call this function again, and just to show you that we still get the expected output, nothing is actually different. So that means that MATLAB actually recognized this function and called it successfully. Now, because this is a function inside of a function, we can only access this function, the mean, from inside this function, basic stats. So if I call the mean here, oops, I meant to actually write the mean, then MATLAB says unrecognized function or variable, the mean, even though it ran successfully here inside the function. Okay, so now I'm going to put a breakpoint on line 44 of this code, which is actually inside the function theMean. So now we run basic stats again, and now we are stepped into this function. So now I'm going to type whose, and we only have one single variable in the workspace here in this stack, and that variable is x, and that is the only variable that exists so far inside this function. Now you might think that we should also have y here, but when you put in a breakpoint, Matlab stops at but not running, including running that line. So this line of code hasn't yet been run. We can of course run this line of code, and then if I type whose, I will get x and y. Okay, and now we can click on editor and function call stack, and now there's three stacks in here. We have base, basic stats, and theMean. And each one of these little stacks only has access to its own variables and its own parameters. There is actually two things I would like to point out about this subfunction. One is that when you're using function inputs and function outputs, Matlab doesn't care about the name of the variable. Matlab only cares about the position of the input variables. So here, this is actually calling theMean invar, because that's what I called it up here. So the input variable name here is invar, but down here it doesn't matter that we have a separate variable name. Here I'm calling it x. Matlab recognizes that variable x is assigning the input to this variable x. And same for the output. Here the output is called y, and here the output is called theMean. Okay, so that's one thing I wanted to mention. The second thing is this function, this is a terrible, terrible name for this function in context of this script, because I use theMean. It's almost exactly the same, except for the capital M and the lowercase m. So here I say theMean with lowercase m is a variable, and theMean with uppercase m is a function. So terrible programming, but I wanted to do that on purpose to make this point explicitly. All right, so I want to get rid of this breakpoint. So you can click on this red dot as I've shown you before. And just to show you, you can also click on the editor tab and then on breakpoints. And on the current line, the line where the cursor is, you can add or remove a breakpoint, also with a keyboard shortcut F12. What I'm going to do is select clear all. So this is going to clear all of the breakpoints in the files, even if there are more than one. Okay, and then I will exit, quit debugging, and basic stats. I'm just going to run this again just to show you that now it runs fine, we don't get any errors, and we're not stepping into the function because we've gotten rid of all of the breakpoints. Now, there are two other methods for stepping into functions that I would like to discuss. One is without clicking on any of the individual lines, you click on editor and then breakpoints. It's actually, you click here on run, and then we want pause on error. Okay, so what that's going to do is step into a function when MATLAB detects an error in that function or in any function. So first I just want to run breakpoints again just to show you that nothing happens, we still get the expected output. What I'm going to do now is change the spelling of this variable and then save the file. So now I expect that MATLAB is going to produce an error on this line because this variable does not exist with the capital R. It's misspelled. Okay, so now what happens is MATLAB gives us an error message, unrecognized variable in var with a capital R. It tells us exactly where the line is that produced the error. It tells us what the error line was, and it steps in directly to that line. And it also, this is a link. So if you move the cursor somewhere else and you click on, I think I'll even open up a blank script here. And now I'm going to click on this hyperlink, line 27 of basic stats, and MATLAB will immediately take me to the script. In fact, I'll show this to you even more. So now I just close that function file altogether. And now I'm going to click on line 27 here, and MATLAB opens up that file and puts the cursor immediately in the line that causes the error. So I use this procedure quite often, stop on error. It's really useful for debugging, as you can imagine. So that's for stepping into a function when there is an actual error. Sometimes you need to step into a function because it's doing something weird or unexpected. It's behaving in a way that you didn't predict, even though it's not necessarily an error. So in that case, there's another little trick that you can use. And that is you can right click here. So if you left click, actually I have to save this file to set this breakpoint. So here we were left clicking to toggle a breakpoint. You can also right click and so you can do select set breakpoint, but I'm going to select set conditional breakpoint. So breakpoint will break in all the time, and a conditional breakpoint will allow you to specify an option for when we should step into the function. So we can say something like, and this has to be a conditional, this has to be an expression that returns a Boolean true or false. So maybe we want to say something like, if the sum equals NaN. NaN is not a number, it's what happens when you divide by 0, for example. Okay, now I press OK. Notice that this breakpoint turned yellow instead of red. So now let's see, I'm going to run basic stats. Okay, this was fun. I didn't actually expect this. But what's happening here is that this variable, the sum, hasn't yet been created because it didn't run this line yet. Okay, so I'm actually going to, let's get rid of this. I will put that breakpoint here. So set conditional breakpoint if the sum equals NaN. All right, and now db quit to get me out of this. So I run basic stats, and now we don't step into the function. We get the normal output. Matlab completely ignored this breakpoint because it tested for this conditional, the conditional that the sum equals NaN, and that conditional was false. So Matlab just ignored that breakpoint. But now if we add an NaN in here, oh yeah, right, I forgot. So the function that we are actually looking for here is called isNaN. So we want to say is NaN the sum? So this is going to return true if the sum is NaN, and it's going to return false if the sum is not NaN or not a number. Okay, so now let me run basic stats again without the NaN, and now we get nothing, we get the normal output. We don't step into the function. And then if we run this again with NaN, then we step into this function at this line, and that's because this conditional was true, so MATLAB enabled the breakpoint here. And now we have access to all of these variables. Okay, so this is one way to create a conditional breakpoint. I actually prefer a different way. The thing is, as soon as you close this MATLAB session, this breakpoint, including the conditional, will be destroyed. It will be gone. So what I actually prefer to do is something like this. You can say, if is NaN the sum, then you can say something like I like chocolate equals true. Now the thing is, now the advantage of this is, let me get rid of this. So db quit. So now I can put a breakpoint here, and then the idea is, if this is false, then this line never gets run, so this breakpoint isn't going to get run. So let me show you that. Basic stats. So now everything should be fine. We get a result. We don't actually step into this function because this line is not run. On the other hand, if we include NaN in here, then this statement is true. So then this line gets run, and then we get a breakpoint here. Now, of course, the breakpoint will disappear as soon as you close the MATLAB session. So you will still need to manually re-add this breakpoint here. However, I find this a better procedure because the conditional for breaking into the function, for stepping into the function, is always there from MATLAB session to MATLAB session. So this was quite an information-rich video. I introduced you to the concept of stacks or workspaces, which I like to call Miniverses and Tiniverses. I showed you several ways to step into a function using breakpoints. Stepping into functions is really useful for debugging, And it's also really useful for understanding how existing MATLAB functions that other people have written work. So stepping into a function and running that function line by line is a great way to discover MATLAB programming and to make yourself be a better programmer.